In this lesson, we will review an answer to the optional test problem in our Intermediate Field-Driven Design course, which asks you to create this woven pattern that is planar, cylindrical, and spherical. I say that this is an answer because you could have something that maybe has a slightly different process that comes to the same result, and that is fine as well. But we start with that starter file that gave the inputs, the radius for our columns and rows, how many we want, spacing, and the magnitude, as well as equations that we'll use for remapping to get that woven interlocking pattern. Something else that I use often in this is using our variables before to make this automated. So eventually, when we get to the end, you'll see that I can change the numbers of columns and rows, and it'll quickly adjust for that. So you maybe didn't include this aspect. Definitely recommend if you're doing something where you want to maybe change those inputs, you could make this into something like a custom block. So again, if it's a little bit different, that's okay. And if you are interested in taking your workflow and automating it, being able to have those variables change with that design changing instantly, then you can also go to our Intro to Automation course to get started on learning a little bit more about that. But the first thing that we do is just start by creating our beginning column and row. And already I'm starting to use variables that I have. So with both of these, I have my column 1 and my row 1. And I'll show those both. I have them as different colors to make it a bit easier to follow along. And so our starting point, I have our point defined here, which is really just a scalar value, but this is going to be the spacing times 2. And the reason for this is I'm just giving space for that row to start. And our final point, we're going to make this as long as the spacing times the number of rows. So we make sure that if we're changing that spacing, we're changing those rows, this will be a long enough size. You didn't have to have all this automation involved as well in your design, but just showing this example in this way. And if you also want to follow something that starts from scratch, you can also watch our training video that goes through each of these steps from scratch, linked below this video. So we have row 1, which now instead of having our x value be that point, we're just going to have that as our z. And again, we're just going to make this as large as that spacing times the number of columns this time, and use the radius to create that. So we have column 1, we have row 1, and you could make the same thing for column 2 and row 2, but to show how we can use that translate object and that remap field, I use remapping to create our column 2 and row 2. So since I'm just moving this over, I'm moving it by that spacing. And since we're moving this in the positive direction, we're going to do a subtract. So if we look at our column 2 and our row 2, and really the only difference is that I'm moving one along the x, one along the z. And the reason I have this is because we'll have a sine wave going kind of in one direction and then in the other direction so that we have that interlocking pattern. So we're going to have to start with 4 cylinders. So we have these 4, and the next thing I want to do is create an array. So that's where we'll use the remap again for the mod. But of course, this is just showing that intermediate fields, how remapping works. You could always just use an array body as well too. A little bit easier as well. So I'll talk about the bounding blocks in a little bit, but let's just look at what I'm doing for something like our row 1. So x and y will stay the same. We just want to see that change over the z. We want to have it repeat. So if I type f, let's change our plane from normal to be 0, 1, 0. And let's actually look at that mod. So I'm taking the z-axis and 8 millimeters, which in this example is that spacing times 2. And that's going to give me, if I put an interval of, let's do 4, and put my values, we can see that it's going from 0 to 4 to 8, and it's just going to continue to repeat that. because I have this as my coordinate system, anywhere we have that location that we have our first column will just be repeated. And if I type F on our remap field, we can see that that is exactly the case. So anywhere we see that dark blue to pink, that's where our columns are being placed. Now these are going infinitely up and down that z-axis, so that's why we have our bounding box. And that's just going to make sure we only take the amount of columns that we want in this area. So I eventually want 8 columns, so I have 4 in this first bit, and then I'll take my rows 2, mod that, and use the remap field to have an additional 3 with that starting row. And our bounding box, I'll show that as well too. So our point 1, I'm going to have this origin for the x and the z, and then just bring that down -2 millimeters, or that radius dot negative. So we just have some space, and I just multiplied that by 2, so we have some space on that side too. Then for our max point, I'm taking the number of columns times the spacing in the x, number of columns times the spacing in the z, and then just 2 times the radius, so we have a little bit of space in between those. So you could also change this as well if you wanted a bit more spacing at the top and bottom. Or you wanted this to be maybe the radius plus the spacing or half the spacing. You can play around with that. This is a pretty open-ended problem. So a lot of ways you can go about it. But so I have my bounding box, and I'm going to do the same technique for my rows 2. Again, I'm just now taking row 2 instead of row 1, but same mod used values to get my other rows. And for the columns, similar thing. This time though, we're just going to have that mod block in our x input because we'll have those columns go along that x. So that's columns 1 and columns 2. So now I have the rows and columns that I need. You technically didn't need to use remapping for any of this quite yet, but just to show those techniques, I wanted to show that. But you could always have done a translate object, you could have done that array body, a lot of different options. But now I have 4 major groups that I'm going to use for remapping. So I have rows 1, rows 2, columns 1, and columns 2. And I do need those 4 sections because we'll implement different remap fields using the equations provided in our starter file to create our woven pattern. And we also have them defined of which equations you'll use for row 1, row 2, column 1, column 2. So I'll open up this remapping with the sine equation. So a little bit different than what we discussed so far. That's why this is a bit of a challenge problem. And what we're just going to do is take the y, and we're going to multiply the magnitude and the sine equation that you have and just add those together. So if you look, we have that magnitude, and I say used in the sine wave remapping. If you don't change the magnitude, then if you don't have it, that's okay. But it's nice to have that if you did want to change the magnitude. And if we see that, it's going to create our wave. And let me show what this looks like if I type F. Turn this around. Is we're getting this kind of wavy pattern. And the reason for this is if you look at this magnitude times that sine equation and probe our values, we're getting something that is going from -1 to +1. And as we're going along that and adding this to the y, we're changing those values that we have and just creating this wavy shape. So we just get something like this, and this is how we are creating that column or that row in this example. So they all are changed in this way. And that's also why we need to have 2 separate rows, because we just have 2 separate sine equations for that. So in this one, this is x minus the spacing, and then this one is just x. And this allows us to just have that sign going in the opposite direction. So we just shifted it over Similar process with the columns 1 and 2. Really the only difference between kind of these is which equation you are putting in, which is why we have those different ones. So this is that x minus spacing, that one was x. This one is z minus the spacing, and the other one is z. So that just allows us to, instead of having that wavy structure along that y or z, to then have it along the y and x. So just changing that. So I have those 4. And then I'm pretty much done with the remapping in order to create this planar weave. We can see it looks pretty good. And something I'll just show with this as well. And the reason I wanted to have those variables all connected, shows a cool option of that automation, is I can change this radius. And what it has done is now also change my part pretty quickly. So something to note is I do have some of that excess. A key part of this is just because of kind of that spacing that I had as well too, and just creating that bounding box. So this is just an example. If you want to, maybe yours looks better than this and has, even if you change that radius, change any of these areas, you won't have that kind of excess. So I could always go back and change that bounding box to fix anything like that. But this is our radius. You can see I can also change the columns. And same here, so I'm going to actually make this you can see what that looks like. Now, having 9.67 of a column doesn't always make sense. So I would say for these, definitely make them round, but you can see that this is pretty quick to change. Make that 3. And our bounding box changes with that as well. And for our magnitude, if you wanted to see why we even included that, I can change it, and you can see how that magnitude changes as well too. So if I didn't want it to be, and maybe I wanted it to be connected fully, I didn't want any space in between them, or I wanted a lot of space, I could always change that magnitude. But I'll go back to that 8 and 8 that we had before. And if you're going through this, maybe you don't see this change in real time, you can always go to your File, Settings, and enable GPU acceleration. So this just allows me to see that change happen in real time. And it's definitely neat to explore and play around with when you're working with fields especially. So in order to finish this, let me open up my final for our planar weave. All I do is a union of the rows, union of the columns, and then union of everything all together. So that's one way you could go about it. Another way you could choose to do is use a concatenate list block. So instead of having to do this Boolean union 3 separate times, I could just bring in those different lists I have, concatenate them, and Boolean union those within that. So if you are unfamiliar with concatenate lists, you can always go to our documentation on this as well. And in our Intro to Automation course, we show some examples on that. So that's our planar weave, and we'll use this as our basis for creating that cylindrical kind of basket pattern and that spherical one as well. So I'll open that up, and I'll also go to my view and go to my display grid, because we'll need this when thinking about how we create that cylindrical remap. So first what I'm doing is orienting this object differently so that I have this ready to go for our remap cylindrical field. So I start with my object, which is that planar weave, and you can see I just have this at our centroid of that bounding box, and then for our destination, I'll show this. I've just placed it here, and the reason for this, and we can see I have this as the spacing times half the rows divided by pi for our x, and then I just have it at the centroid for the y and z. And I need to place this so that when I am wrapping this around, it'll take this entire woven structure and wrap it around. So having that spacing times half the row divided by pi is going to allow us to then place this into our remap cylindrical field and be able to get the result that we want. So if I put in this for my field, the Y mapping length as the spacing times the number of rows, so that's just how long it is, and show that, but I can't click on this toggle visibility because if I do, it's actually infinite. So I'll show first this Boolean intersect so we can see what that looks like. And we can see it's starting at that same location and it's just wrapping it around. So that's our radius of the wrap, I guess. And it's just going to place that nicely. We get this final result like so. I can also change this box from corners, so that was a little bit too loud. And this one I didn't end up automating. You could also automate this as well too. Just wanted to show some different examples. So you probably have different box from corner values also. The reason I have to do that Boolean intersect is if I look at our field and type F, and I'll change our plane from normal to be 0, 1, 0, is we can see we have these dots coming all the way through. So that's just our designs that we're working with, going around like so. And that is just wrapping this part. So with the cylindrical weave, we took our oriented object, we've wrapped it around, but now we have it all up and down that kind of z-axis. We're going to have it wrapping and continuing to do so. So with something like this, that's why we have to have that Boolean intersect. And if I look at my designs here, I can see I don't have the same amount of columns, and I'll just have to play around with my bounding box to just include more or less. And eventually, we can see our column stops and we only have those rows because we have that defined height while our rows will just continue on. So if you have that box from corners, maybe you have that so it defines it exactly as that height of the columns and the amount of rows that you have, but just showing this example, let's create something like this. And then the last thing we'll do is that spherical remap. And so this is our spherical remap where we have our oriented final body again as our part. We can use that same one we had for the cylindrical remap. Now we have just the spacing times the number of columns and spacing times the number of rows. And note here that while we have 8 rows, we really only have 4 of these. So if we look at that oriented final body again, we're just going to take kind of a portion of that and wrap it around. So we'll just have that 4 going kind of up and down that part, and then 8 of those columns. So you could change this. So maybe I want this to be 12, 12. Get something like this. But something to note is if you make this uneven, so say number of columns 8, for doing our cylindrical remap or our final planar weave, that's fine, but you can notice that we're starting to not have this connect once we start adding more and more to that. So you're going to want to either make it even, or if you do want kind of a basket with that opening, then do a Boolean intersect of kind of that box that you want left, that little basket. You can do that as well too. You can change that spacing. I can show it the opposite way it looks like. So 12 for the columns, 8 for the rows. And we can see it also will kind of stop halfway through there. So maybe that's the kind of design that you want. You can definitely play around. And that's how you can create that cylindrical woven pattern, spherical, and planar woven pattern. So this definitely was a more advanced example. So if you want to see a step-by-step on this in more detail, definitely check out our training videos just showing how we can take those concepts we learned in the previous lessons and apply this to a real design.